Well, hello and welcome back to part 2 now of our 7-1 notes. Part 1 talked about Pythagorean Theorem and how we could apply that to triangles, to stories. And now we're going to look at the converse of that. So if you remember, converse meant that we took our theorem and we flip-flopped the setup and the result. So what we had as our setup before is now going to be our result. What we had as our result before is now going to be our setup. So the phrases in the converse are actually very, very similar to the phrases in the original. So we're going to fill in the blanks with the same words. It's just in a different order. So on the converse of the Pythagorean theorem, instead of starting with a right triangle, we start with, does the equation work? If the equation works, then the triangle is a right triangle. So to officially fill this in, if the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So that first part, it's a mouthful, but it's the same mouthful we had at the end of the Pythagorean theorem. That part is establishing, hey, there's this equation, a squared plus b squared equals c squared. If that all works out, then the triangle is a right triangle. Now, I know that seems kind of weird, but what this lets us do is use that Pythagorean equation to check and see if triangles are actually right triangles or not. So, of course, we have some examples to do. So, in this first example for this part, number 4, we're considering this triangle here. Is this a right triangle? Now, it tells us specifically it's not drawn to scale, but you might have been able to tell that already because this 2 side is way too big if this 6.1 is correct. So obviously this is not drawn to scale, which means while it doesn't look like a right triangle, since it's not drawn to scale, the looks don't matter. They could have drawn this as a, I don't know, not a circle, it would still be a triangle, but they could have drawn it all kinds of ways. They could have drawn the 2 to look bigger than the 7. It's not drawn to scale, so we can't use the way that it looks. We have to use some kind of other way of telling if it's a right triangle. So we're going to use the converse of the Pythagorean theorem. So we're still going to be using this idea of a squared plus b squared and c squared. But this time we don't know if the squares of the legs are equal to the square of the hypotenuse. We're checking to see. But here's where that gets kind of weird, because we don't really technically have a hypotenuse here. There's no right angle that can help us find the hypotenuse. So to figure out which number is c, the hypotenuse is always the longest side of the right triangle. So if there is a hypotenuse here, it's going to be the longest side. So we know all 3 numbers, 2, 6.1, 7. We just take whichever one's biggest. Well, 7's the biggest. So 7 is going to be our c. And 6.1 and 2 will be our others, our potential legs. Okay, so now hopefully you have a calculator handy, because I don't know what 6.1 squared is. Let's see. 6.1 squared, 37.21. I do know what 2 squared is, 4. Now we're checking to see, does that equal 7 squared, which is 49. Now, here's one thing I'm going to tell you as far as working later, working on your assignment, eventually knowledge check on this stuff. This step right here, I need to see this step before you give me your yes or your no. So the setting up of putting the numbers with the squares, that's great, but I need to see that evaluation of the squares. I need to see what your a squared actually comes out to be. What does your b squared actually turn out to equal? Once you've got that part, if you wanted to add this up in your head and compare it to 49 in your head, that's fine. But I need to see those exponents evaluated. I need to see all 3 numbers after you've done the exponents. Okay, if you're not wanting to do this in your head, we'll just add up 37.21 plus 4. You can use the calculator if you want. We'll get 41.21, which in fact does not equal 49. So as far as the actual question, is this triangle a right triangle? Well, if it were a right triangle, we would have come out equal on both sides, and we didn't. So no, this is not a right triangle. And on your assignment, I'm going to ask you to explain. And here's how you would explain. Because the Pythagorean, you can abbreviate Pythagorean because that's a really long name. Pythagorean equation is not true. Now, there are a couple different ways you can word this, but if you're specifically saying that something's not true, you're talking about the equation. Saying that the a squared plus b squared equals the c squared, that was not true here. A squared plus b squared did not equal c squared. So our equation is not true. If you're trying to talk about the theorem, you could say the theorem didn't work, but the theorem is always true. It's just whether it works for your situation or not. So this would be a full and complete answer for that problem. Okay, we got one more. Because the nice thing about this, about using the converse of the Pythagorean theorem, we don't even have to see the triangle. Even when we do see the triangle, it's not really that helpful, like if it's not drawn to scale in number 4. But as long as we have all 3 sides, we have all the information we need to be able to put this into Pythagorean equation. Because it doesn't matter, we don't have to find the right angle in the picture. We know C is always going to be the longest side. 71 is bigger than 36 and 42. So 36 is going to be maybe our A. And then maybe 42 is our B. And then 71 is definitely our C. Okay, and these numbers are huge, so calculator it is. 36 squared, 1296. Okay, 42 squared, 1764. We're checking to see, does that equal? 71 squared, 41. So as long as you have this step written out where you've evaluated your exponents, you can do the rest in your head if that's something you're comfortable with. But for me, I'm going to go ahead and 1296 plus 1764. Oof, 3060? That's definitely not equal to 5041. This one wasn't even close. So again, our answer is actually the same as in number 4. No. And here's a different way you could word it. Because the, whoops, spell it right. Pythagorean theorem, so notice this is a different way of wording it, didn't work. Now, you can't say Pythagorean theorem isn't true because it's a theorem, it's always true. You can say the equation isn't true, you can say the theorem didn't work. You have either one, pick one that works for you. Okay, we have one more example. A story problem, because we gotta love the story problems and how we fit this in. Okay, so a farmer fenced in a pasture for his sheep, and he'd like it to be square. He made sure each of the 4 walls, well, 4 sides of the fence, each of those was 350 feet long, but he's not sure if he actually got right angles. He did measure the diagonal of the pasture, and it was 470 feet. Did he achieve his square? So we've got this fence. He's hoping it's a square. We've got 370 or 350 on all the sides, right? And where he gets into potential trouble is that it's possible to have all these sides be the same, but have it slanted. These sides could all be the same without having right angles. So this is where maybe he got it because he did make sure every side was the same, but he doesn't know if he actually got right angles. So what he did, he measured from this corner to this corner and found out that that's 470. And now he's curious, is this a right angle? So at first it looks a lot like our soccer field problem from part 1, but we're testing something different. We already know how far it is across that diagonal. We're trying to figure out, does this actually work? Okay, so let's set up our Pythagorean equation. We've got 350 squared plus 350 squared. Does that equal 470 squared? That's our big question. Now, I'm going to give you guys a hint that I didn't give my other classes because you're doing this e-learning. That makes it harder anyway. Notice that this is exactly the same as this, right? So these are like terms. You're not going to see it like that on your assignment, but if you had like a squared plus a squared, just in theory, maybe if that came up that you had a squared plus a squared, you can combine those. We could say this is the same as 2 times whatever 350 squared is. We're still trying to see, does that equal 470? Now, I will tell you, this is not the easiest way to solve this specific problem, but when we're talking about squares, this idea shows up. Anytime you have a square with your Pythagorean theorem, since your A and your B are the same, you end up with this idea where you can do 2 times just the a squared. So like on the left here, this is the same as 2 times a squared. And where that will help you later, again, not the easiest way to do this problem, but where it'll help you later is, let's say I have this number. So 470, let's go ahead and square that, get that giant number. This equals 220,900. Okay. What I can do now, I can divide both sides by 2, and then I have just the 350 squared, equaling whatever that is. So 220,900 divided by 2, 110,450. So keep that idea in mind when you go to do your assignment. If something represents a square, think about, well, the sides have to be the same, so I don't need an A and a B. I just need A's. And if I have 2 a squareds, I can write that as 2a squared. And if I have that, then I can divide by 2 on both sides of my equation. Then we just end up with the a squared equaling whatever the number is. So I know it's kind of weird for this example, but it will help you later, I promise. Okay, back to this problem. Now we need 350 squared. And we're going to see, oh yeah, we're still checking to see, does that equal? So 350 squared, we get 12250, and that, oof, does not equal 110450. 1, 2, 2. I missed a 0 with that. Still not equal, but it's closer. He actually wasn't far off. So as he was making it, it probably seemed about right. It was just slightly off. So unfortunately, he did not achieve his square. And if I asked you to explain how you know, because the Pythagorean equation is false. It didn't work. It's not true. Either way. Okay, so number 6. That was just a story problem to apply it. I did sneak in a little hint for a homework problem. I have another quick hint for one of the homework problems. So there is a situation that comes up. If one of your sides looks like this, a number and then square root another number, like let's say 3 times the square root of 5. You can use the calculator. Where'd it go? There we go. To get a decimal for that, 3 square root 5. And then do whatever you need to do. But the trouble comes in because we need to square this. And there's a couple different ways we can handle that. Come on. Okay, a couple different ways we can handle squaring that idea. In general, the algebra way to do this, if we have h square root k, really we have a product here, and we need to square it. It's the whole thing. If that whole thing is your c, it's one of your sides, in Pythagorean theorem, we have to square that side, so we're squaring that entire thing. Now the exponent rule says that you bring this exponent into both pieces. So then we'll have h squared and we'll have square root of k, whatever that is, squared. Now, h was just a number. You can easily evaluate that square. We're going to actually do this with the 3 square root of 5 so you can see how it works. When we look at this part, though, since we have a square root, but then that whole thing is getting squared, that's going to cancel out. So what this ends up giving you, you do have to evaluate the h squared part, whatever your number out front was. You still have to do that. But then you're just going to multiply it by whatever your radicand was originally. So the squared is going to cancel out the square root that it had, and that'll be your answer for the squared version of that weird looking number. Okay, so let's try it with this one. So if I need to square this, let's say that was my c and I need c squared. I'm going to bring that exponent into both pieces. So it's going to be 3 squared times the square root of 5 squared. Now 3 squared is 9, right? But then this part, the square root and the squared will cancel, and I'll just have to multiply by 5. So total, we would have 45. That would be my c squared version, if 3 times the square root of 5 was my c. So that may help also. The other thing you can do in your calculator, why do I have so many things? Okay. If you put parentheses around it, you're like 3 square root 5, right? So same idea as we had right here. And then put your squared on it. It'll simplify it right away for you. So you can do it by hand. You can do it in your calculator. Just make sure you put in the parentheses. It's very important. Otherwise, you won't be squaring the whole thing. So either way will help you with one of your homework problems. Okay, I'm sorry I've talked a lot, but hopefully that gets you everything you need to be able to comfortably finish your assignment even though I'm not there with you. So there is an assignment. Check the post on Google Classroom. There's a PDF. There's a Google Docs. You can work it whichever way. There were a couple of you who actually got the paper assignment from me, so that's probably the easiest way. If you can print it, that'll be easy for you as well. But if you have any questions, please email me. I will tell you, it is easier for me to appropriately answer your questions if you send me a picture of the work that you've done so far on that problem. Don't send me an email that just says, I don't know how to do it. Try it. Try something. Send me a picture of that, and then we can have a back and forth about what you can try next, what you've tried, why it didn't work, all of that. So I'm available by email all day. Just send me an email with a picture, and we'll try and get you all squared away so you're ready to turn this in on Wednesday when I see you again. So thank you so much. Enjoy your e-learning day. Enjoy your long weekend, and I'll see you guys on Wednesday. Thank you.